All right, welcome to the Explainer. Today, we're going to talk about something that is so critical for AI security, but honestly, it gets overlooked way too often. We're talking about encryption, and not just as some nice-to-have feature. Nope, we're talking about why it's a non-negotiable for literally every single piece of data your AI ever sees. So, let's just kick things off with a really important question that, frankly, every single person using AI needs to ask themselves. You've got this incredibly powerful AI, right? It can do amazing things. But is its data actually safe? Because if it's not, you're basically building a skyscraper on a foundation of sand. It looks impressive, but it's just waiting to collapse. And to really get to the bottom of that question, we have to look at something I call the AI data blind spot. See, it's so easy to just focus on the shiny new model, right? The brain of the operation. But the real danger, the place where things go wrong, is often hidden in the massive, sprawling footprint of data that flows in, out, and all around that model. So when you think about AI data, what comes to mind? Probably just the prompts you type in and the answers you get back, right? Well, that's just the tip of the iceberg. I mean, look at this list. We're talking about the training data, these things called vector embeddings, all the requests, the logs. Every single one of these is a potential goldmine for an attacker. If this stuff isn't locked down, you're exposing incredibly sensitive information. Okay, so what's the solution? How do we deal with all these different risks? Well, instead of playing a frantic game of security whack-a-mole, trying to patch every little hole, there's a single powerful rule that changes everything. It's this: you have to encrypt your data at every single stage of its life. No exceptions. It's not about picking and choosing what to protect. It's about creating a comprehensive shield that covers everything. All right, let's break this down. First up, we're going to tackle protecting data at rest. Now, what does that mean? It's basically all the info your AI system is just storing, the stuff that's sitting on a hard drive or in a database somewhere. And believe me, AI systems store a ton of data in a lot of different places. We're talking about the massive data sets they're trained on, the model files themselves, a history of every single prompt you've ever typed, and yeah, those vector embeddings we mentioned. Every single one of these is a target, a potential point of failure just waiting for someone to find it. And the difference between protecting this data and not? Well, it's night and day. I mean, look at this. If you leave your data unprotected, just sitting there in plain text, you're basically leaving the front door wide open for disaster. We're talking IP theft, exposed customer PII, massive GDPR or HIPAA fines, but with encryption, it's like a vault. Even if someone manages to steal the hard drive, all they get is a bunch of useless, unreadable gibberish. Okay, so how do you do this the right way? It's actually pretty straightforward. First, you use strong industry-standard encryption like AES 256. Don't mess with homegrown stuff. Second, you apply it everywhere: cloud storage, databases, you name it. And third, and this part is absolutely crucial, you have to manage your keys securely. Use a proper key management service. You do these three things, and even if someone breaches your storage, the data itself is still a locked box. They can't get in. So, locking down your stored data is step one. But that's only half the battle, right? Because data doesn't just sit still. It's constantly moving between systems. And that moment, when it's in transit, is often when it's at its most vulnerable. And modern AI systems are, well, they're incredibly chatty. Data is zipping back and forth all the time. From you to the AI, from the app to the model's API, from the model to a vector database, from the AI to some third-party plugin. You get the idea. Every single one of these pathways is a place where someone could be listening. You know, sending data across a network without encryption it's literally like writing your company's most valuable secrets on the back of a postcard and dropping it in the mail. Anybody along the route can read it. But when you encrypt that data in transit, now you're using a locked, armored truck for delivery. It completely protects it from snoops and prevents those nasty man-in-the-middle attacks. And the absolute key here is to be consistent. You've got to enforce modern security protocols like TLS 1.2 or newer for all communications, and I really mean all of them. Don't just secure the traffic coming from the outside world. That internal chatter between your own microservices, yeah, that needs to be locked down just as tightly. Okay, now we're going to get into what might be the most surprising and, frankly, the most overlooked risk of them all. It's a type of data that's pretty unique to modern AI, and a lot of people just don't realize how dangerous it can be if it's left exposed. We're talking about vector embeddings. So what on earth are these things? Well, think about it like this. When you use a system like RAG, you feed it all your documents, legal contracts, HR policies, secret company plans.
The AI can't read text directly, so it converts all that information into a mathematical format, long strings of numbers. These are the vector embeddings, and they're how the AI understands the meaning and context of your data.
So you look at these giant strings of numbers, and they don't look like anything, right? It's not human readable. So they must be safe, right? What's the risk? That assumption is incredibly dangerous. Thinking that just because it's a bunch of numbers, it's safe, that is a critical mistake, and it can open you up to a huge, completely unexpected security breach. So how can a bunch of numbers be dangerous? Well, it's pretty scary, actually. Skilled attackers can take these embeddings and start to reverse engineer them. They can figure out what the original data was. They can launch attacks that actually trick your own model into spitting out sensitive information. Suddenly, that entire knowledge base you fed your AI is completely vulnerable. Let's walk through a quick real-world scenario to see how this plays out. Picture this. One of your employees goes to the internal company chatbot, the AI assistant, and asks a totally normal question. Something like, hey, what's our policy on parental leave? Seems harmless, right?
Okay, so to get the answer, the AI dives into its knowledge base, which is all stored as vector embeddings. But here's the catch. That database doesn't just have the public employee handbook. It's got everything. It's got embeddings for confidential legal files, secret financial plans, and every sensitive HR document in the company.
And that is the failure point. If that vector database isn't encrypted, a single breach of that one system now exposes the company's crown jewels. An attacker gets in, and now they can start piecing together your most sensitive knowledge. All of a sudden, your helpful little AI assistant has become a massive, ticking time bomb of a liability.
So, when you put all of this together, the data at rest, the data in transit, and this crazy risk with embeddings, it leads to one very clear, unavoidable conclusion about encryption's role in the world of AI. We have to start thinking about this differently. For a long time, encryption was considered a best practice. Something you should do if you have the time. That mindset has to change. In AI, where data is literally the fuel that makes everything run, encryption isn't optional anymore. It's a baseline security requirement. It's as fundamental as having a lock on your front door. So, if you take one thing away from all of this, let it be this checklist. It's simple, it's actionable. Are you encrypting your data at rest? Are you encrypting it in transit? Are you encrypting your vector embeddings? Are you securing your keys? Is this all part of a bigger zero-trust strategy? If you're working with AI, you need to be able to say yes to every single one of these. And I'll just leave you with this final thought. If your AI system is handling sensitive information and you haven't encrypted everything at every stage, you don't really have an AI solution. What you have is a risk accelerator. It's a machine designed to take your most valuable data, put it all in one place, and make it a giant, glowing target for attack. Without encryption, you're not just failing to solve a problem, you're actively creating a much, much bigger one.